In this course, I'll be focusing on devices that use a third category of materials that exist somewhere between conductors and insulators called semiconductors. Semiconductor materials are able to conduct electricity, but only partly. They can conduct current better than an insulator, but not as well as a conductor. The most commonly used semiconductor material is silicon, which is used to manufacture everything from computer chips to solar panels. Silicon is popular because it's relatively cheap, it has good electrical properties, and it's easy for manufacturers to fabricate into electronic devices. To make silicon useful for electronic devices, a process called doping is used to inject other elements into the silicon structure to give it more mobile charges. Semiconductor materials like silicon can be doped in one of two ways, called N-type and P-type. The letters N and P refer to the sign of the charge that can move around within those doped materials. So, in an N-type material, it's the negatively charged electrons which can easily move around. And in a P-type material, it's the positively charged holes that move around. Those holes represent an absence of electrons. To make an N-type semiconductor, pure silicon is injected with a small amount of another element whose atoms have one more valence electron to use for bonding than silicon atoms. Phosphorus is commonly used for that purpose because phosphorus atoms have 5 valence electrons, and they're about the same size as silicon atoms, so it's easy for them to replace some of the silicon atoms in the crystal structure. The injected phosphorus atoms use some of their electrons to bond with their 4 nearest neighbors, like a silicon atom would, but since the phosphorus atom has one more valence electron, that spare electron doesn't get tied up in a bond. That extra electron from the phosphorus atom can move around amongst the silicon atoms relatively easily, which gives the N-type doped silicon more mobile negative charges to use for conducting current. To make a P-type semiconductor, the pure silicon structure is injected with another type of element that has one less electron available to use for bonding, like boron, which only has 3 valence electrons. One common misconception about doped semiconductor materials is that N-type materials are negatively charged and P-type materials are positively charged. In actuality, N-type and P-type semiconductors are both neutral because the individual atoms of silicon and phosphorus and boron that make up those materials are each neutrally charged because they have the same number of electrons and protons inside of them. The terms N-type and P-type just refer to the types of charge that easily move through the material, either negatively charged electrons or positively charged holes. On their own, N-type and P-type silicon are not all that exciting. They're just materials that conduct well. The magic really happens when they're used together. Semiconductor components like diodes and transistors have structures that contain both N-type and P-type materials. Certain combinations of those materials produce components that behave in different ways when certain voltages are applied to them, and can be used to control and direct the flow of current through devices to create everything from power amplifiers to digital computers. So, I've taken a semiconductor like silicon, which on its own can partially conduct electricity, and have injected it with boron or phosphorus to give it more mobile charges so it can conduct electricity better. Why does that matter?